I am a physicalist. In my view, only things that have a physical representation can exist. The laws of physics are based on determinism. This is why free will does not exist.
I'm also a physicalist, but I don't think everything is as determined as you believe.
Not as I believe, but as the laws of nature are.
But when it comes to the brain, there's no consensus.
Oh, really? What alternative is there?
The theory of neuroscientist Peter Tse. He says that neurons are causally related according to certain criteria.
Causality is based on logic and laws. It can be clearly understood.
That's Newton's classical physics. The world then functions like a billiard game.
Our thinking is very metaphorical, and in the West, at least, the idea of causation is very much tied up with the metaphor of impact. So you know the Newtonian billiard ball model, right? So billiard ball A hits billiard ball B, which then is impacted and moves. And billiard ball B has very little say in the matter of what shall become of it because it's all dictated by the presumed Newtonian and deterministic laws of physics.
But the Libet experiment proved that free will is subject to determinism.
Can you explain it to me?
No. How did the experiment work again?
Benjamin Libet conducted the experiment in 1979. A man was connected to an electromyogram to measure his brain activity. Libet proved that the motor center of the brain had executed the command to move the little finger before the person was aware of it. After the motor command was triggered, it took almost half a second for the movement to occur.
There couldn't be better proof.
But the problem is that this has little to do with freedom. Let me illustrate this with an image. Put it in a nutshell, the Libet experiment evolves around the question if this man is free.
Let me guess. This man is not free.
Yes, but he can still move his little finger.
But that's not enough. In his situation, it won't help him much.
According to the Libet experiment, though, freedom is simply the ability to move your little finger. What he understands as freedom is just a muscle reflex.
Yes, that's true.
Peter Tse calls this the first order of free will. He compares it to the freedom that animals also possess.
And other animals I think also have a kind of imagination. So take a jaguar, in the Brazilian swamp. Well, it can look at a capybara and it can think, I want to get to that capybara. I could go this way, it might be, louder, but it's shorter, and this way is longer, but, and it can evaluate sort of its options, but, no jaguar is saying to itself, oh, next year I want to be a new kind of jaguar that, eats fewer tapirs and more whatever, So they're much more driven by instinct than we are.
The Libet experiment only deals with freedom to move one's muscles. But in addition to this, there's an internal freedom that does not necessarily involve muscles. This internal freedom is associated with planning and refers to behavior. Learning a new language is an example of this. Peter Tse refers to this as second order of free will.
Humans have a type 2 free will in that they can choose to become a new kind of chooser. Now, we all do this all the time. I don't know, I might say, well, next year I want to be able to speak, let's say Arabic. Well, I don't speak any Arabic. In a year, I'll have transformed my nervous system to be able to speak Arabic a little bit, and in 5 years I could be reasonably fluent. Then the question is, what led to our imaginative capacities to imagine that, choosing to become a new kind of chooser? What set us so insanely free?
What does that look like at the neuronal level in the brain?
Peter Tse is convinced that more is happening in the brain than just neurons firing electric signals. He believes that the neural code for free will is synaptic reweighting. Neurons change their synaptic values based on various criteria. Neurons receive these values and decode them. This process may occur in phases. Peter Tse uses a metaphor to explain this process.
And the metaphor in this case is the connectome, which is thought to be something like a highway map. But in fact, that's probably a bad metaphor because that is not how the system works. The system is probably much more like a train track system in which in train tracks you have these shunts, right? So that a given piece of train track might belong to many different neural circuits, depending, right? So by analogy, a given neuron might belong to more than one neural circuit and can switch depending on its synaptic weights. So I can take a little portion of train track, say in Ohio, and it can connect New York to San Francisco, one way or another, but there's different ways that train track can connect things. So the given train track, as a metaphor for a neuron, does not belong to a fixed neural circuit necessarily, and that these shunts now depend on rapid changes in synaptic weights.
How should I understand that? Is the brain like a network of trains without a timetable?
You could think of Wittgenstein's theory of language.
You did a whole series on Wittgenstein. The links are below.
Desires and therefore decisions that are expressed in language do not have a fixed definition. They have common criteria, but the exact selection of these criteria is not fixed.
In this book, I really focused on the neural code, and I think it's very Wittgensteinian in the sense that he asks questions like what counts as a bird, what counts as a game, right? I want to argue that neurons kind of operate like this, so that the neural code, at least at a synaptic level, is rather like a late Wittgensteinian causal system.
Neurons function in a similar way. The outcome is determined by criteria that belong together like a family. The electronic function, akin to that of a billiard ball, is only one aspect of how they work.
What neurons are much more driven by is what I call criterial causation. So it's a form of constraint causation in which the constraints are criterial, they're informational. So, and it's mostly driven by rapid and slow changes in synaptic weights. So in this case, going back to the billiard ball metaphor, billiard ball B sets informational conditions or criteria on A for the release of B, namely an action potential, for example. In the case of a billiard ball, it would be like, billiard ball B says, well, if it's, striped and odd, do that. But if it's even and solid, do that. But if it's the 8 ball, do nothing, right? So that would be a very non-Newtonian billiard ball game.
I don't think we'll ever understand that.
But Peter Tse sees ways in which we can. We just have to break away from our familiar way of thinking and look for new answers. Our capacity for freedom empowers us to think abstractly. We can want something for which there is no representation. This is possible because we can recognize patterns and then apply them to another case or situation.
So I might take an operation like rotation, and I can apply it to an operand, and I can carry out mental rotation in my head. I can take pattern recognition operators from, say, vision, and I can apply it now inappropriately, really, to contents of my memory and become aware of patterns like that I'm going to die, And this has given our species a kind of existential set of problems that jaguars just don't face.
Jaguars lead simple lives. All they need to do is hunt, eat, and sleep.
Peter Tse's model can also explain why people sometimes act against their own interests to do crazy things. Abstract models of free thinking can produce unexpected results.
And I might say, oh my God, well, it hasn't rained in 6 weeks, therefore the gods are angry, and I've got to throw a baby into the volcano, right? So no chimpanzee does crazy stuff like that. So we're kind of insane, but it's the same capacity to see patterns in the invisible, sort of behind the curtains, that gives us forms of schizotypy that also allows us to see patterns that no other animal can see, seeing essentially the invisible.
Rational theories cannot explain something like this.
Freedom is achieving the improbable.
So second-order free will is when we're applying our imagination to ourselves with the goal of recreating ourselves. We're choosing to become a new kind of chooser. I'll just wrap up by saying that the freedom of human imagination is really the deep source of human free will. That the second-order free will is really what sets us apart from a jaguar or any other animal. We're not driven solely by instinct, but in addition to instinct, and we're also shaped by the capacity to imagine virtually anything where the laws of physics don't apply. I can imagine being Snoopy flying in a, flying motorcycle over Mars. I mean, there's just seemingly very little limit to what is imaginable.
I can imagine that Peter Tse will be discussed more in the future.
And I can imagine that some people liked this video. They then have the freedom to subscribe if they wish. Thanks for watching. See you next time.